Hello, ladies and gentlemen. Okay, let's absorb some fat. Okay, now where are we? We are in the lumen of your small intestines. I will orient you momentarily, but let's just digest fat for a moment. So we are in the lumen. Here is this is the lumen of your small intestines, right? Okay, what's happening? Bile. Remember our friend bile? Where's it coming from? It's coming from the gallbladder, right? It's like probably most recently where it was. So these bile salts from the liver, stored in your gallbladder, coat the fat droplets. So here's your large, big old flat droplets. Those aren't going into anything, right? We've got to get those puppies smaller. So our bile salts come similar to soap. Remember, it's going to break these guys up. So these little guys here are going to coat them. See how they're like, there's a little here. They're like, dude, we're just going to coat you right here. We're going to coat you maybe in red. See my little coat? They're going to coat them. And they're going to bust them up, right? And they're going to bust them up into these small little things. Okay. Now we have them smaller. We have emulsions, right? They're little micelles. The pancreatic lipases, and the other there's a whole bunch of lipases here. Don't get bogged down with that, right? It's a lipase. Just remember lipase. That's terrible. Let's pretend that I didn't cross that out. I'm getting used to this pen. These break the fats down into monoglycerides, remember, because they're poly, and now they're just one, and fatty acids, and they're stored in these little micelles. Okay, so in some cases, we've recycled some of them. The other ones, they want to go into the cell. They want to get into the bloodstream. Okay, so how are we going to do that? So, you know what? Well, the first thing we're going to do is we're going to move this up so we can see it a little bit better. Okay, now I can see it. Okay, so now you have cholesterol, and how's it transported in the cell? Dude, it just goes in, remember? Yeah. It just goes right in. That's magic. It's magic. This just goes right into the cell. Basically, they come and they just go right into the cell. Nothing really has to happen once they're into the cell. Now, this is the cell in your lumen, remember. They go into the smooth ER. This is just where they go. And then where do they go from there? They go, let me move us over a bit so we can orient ourselves. Where we go. Okay, we're moving over. Now we have gone into the cell and we are now moving over. Okay. So where are we now? Now we are over here, the Golgi apparatus. If you go back to Cell Bio or something, what do these guys do? Basically, their whole purpose is to like deal with fat. So you break things down, you do all kinds of stuff here, you go to the Golgi. So things you need to know. Do not get bogged down with this stuff. Things you need to know. Smooth ER. Right? You moved in. Nothing had to happen. You just moved right in. Right? Smooth ER. Golgi apparatus. You can call it whatever you want. Golgi complex apparatus. Whatever. Whatever you want. Whatever you learned in bio is fine with me. Then how's it going to get out of there? How is it going to get out of there? Exocytosis. See if I can write that. Look at exocytosis. It's going to exocytose it. Just spit it right out of the cell, right? Get out. So it comes in, it processes it, it breaks it down further into different things that can be used, right? So it's a bunch of stuff is happening here, but we're not concerned about that. It comes right in, smoothie our Golgi apparatus, and then it prepares it to be exocytosed out into the cell. Does it go right into the blood? Nope. You are too big. You're big old fat blob. You cannot get in there. But the good news is you have your super fun. Let me do it this way. I think that's all we have here. Vena cava, yeah. Okay. You have, so basically it's like, oh, I just want to get into the blood. Nope. Sorry, my friend. No can do. Where are you going? You are going, what is this? The lymphatic duct. And you don't know this yet, but you will, or you should. You took anatomy, but nonetheless, this is a big old leaky membrane, right? This is a lacteal. It's like a lymph node, but where's it go? It goes to the vena cava. Where's the vena cava go? Dude, back into your blood. So it's going to get there. It's going to get back into your blood, but it's got to go this way first. It's got to go into the lymphatic system. It's got to circle around and do all of its business. And then it does eventually end back up in your blood. Because otherwise, how could you clog your arteries and have a heart attack? So that is the basics of what's happening. It's going right in. There's not a lot of stuff you need to do, and then it's going right in to the capillaries. This is great. And it's being exocytosed. So things you have to know. Let's just review this puppy one more time so that you don't get bogged down with the picture. I'm going to put this picture on Moodle, so don't worry. Okay, you got your bile salts. You need to know that. You need to know where the bile comes from. You need to know where it's made. You need to know where it's stored. You need to know what it does. What does it do? It emulsifies the fat. It creates these awesome little micelles. So things you need to know. Bile salts. Where they come from. Emulsification. Micelles. You need to know that. Dude, how does it get in here? It just goes right in. Awesome. Cell enters by diffusion. Look at that. It moves out of the micelles. So these micelles, the bile doesn't really go with it. It's like, hey, go ahead and buy yourself there. Then it goes to the smoothie R. It gets processed. Where does it go from there? Oh, I know you know this. Golgi. Then where does it go from there? From the Golgi, it gets exocytosed out. Does it go right into the blood? No, it's too big for that. No, you're too big. But you can go to this like leaky lymphatic system that's always green. It doesn't matter what textbook, it's always green. The lymphatic system gets bad press, but I'm working on that. So let's compare that to carbohydrates and how carbohydrates get in, okay? Hold on, let me pull up the carbohydrate picture. Okay, here's carbs. This is gonna make you appreciate our good friend glucose. Okay, our good friend lipids. Okay, here's our carbohydrates. Here's our long chain of starch, right? Look, these break down. So disaccharides, maltose, sucrose, lactose. Remember our friend lactose? Let's use that one. So our friend lactose, right? Lactase that we broke down in lab, right? 1 glucose, 1 galactose. So this is stage 1, the breakdown by whatever we have. Amylase breaks it down in the mouth, and then it gets further digested. Where does lactase break it down? Remember? The duodenum. Because that's where the pH is best for that to happen. So this actually starts breaking down in the duodenum, and then it's coming to the small intestines. Right before it gets to small intestines, it's got to get in, right? It's got to break in through the lumen. This is the little loop on your lumen, right? Okay, what do we have? We have sodium transporter, right? I know we just talked about this. So don't be like too crazy about it, but it's facilitated. It's facilitated transport. That's what happens right here. This glucose gets in with a sodium. Sodium's like, hey dude, you want to go? Because I'm going to go in because my concentration gradient is so that I can just like go right in if you want to go with me. Glucose is like, yeah, I probably need to go in because I heard I make ATP, so I should probably go. So boom, sodium goes in. How does it get out? So it's in, yeah, it's in, but nobody cares about that, right? We need to out. We got to get it out of there because it's got to get out. How does it get out? Okay, again, it's another co-transporter. It's a bunch of things happening here. You have, what is this? This is a sodium potassium pump. I told you, we're already on like time number 3, and we haven't even started physiology yet. This thing creates all kinds of really awesome concentration gradients. So the sodium could come in up here for free, taking the glucose with it, but it wasn't really free because there's a sodium potassium pump down here, and that does cost a little ATP. So then how does it get back out? It gets back out again with facilitated diffusion. So it gets out with GLUT2. We don't know that yet, but it just another sort of co-transporter lets it just go with it. Okay, so that it wasn't bad. That's actually not bad. It comes in with a co-transporter. It comes in with sodium. It's allowed to do that because of the sodium potassium pump, and it leaves then with another co-transporter system. You don't have to know that which one it is. You just have to know that it leaves again. When does it come out here? Okay, is it when we did the osmosis and diffusion? Is the glucose molecule small enough to get out? It is. So therefore it's small enough to go right into your blood. It goes right into the blood and takes you where you want to go. So let's see if I can get this puppy to move, drag to move. It says I can do that, but it's not happening. So that is what is going on with your carbohydrates. Proteins are, again, a little bit more stressful. Oh, and I thought I had a review, but it doesn't. It just has carbohydrates. That is your carbohydrate. Okay, one more thing I want to do. Hold on. Okay, let's look at this guy for just a second. So we've done this. We've reviewed it. Carbohydrates, they go to glycolysis. You get some ATP, you get some pyruvate, you get some acetyl-CoA. Go down here and boom, you get some super fun coenzymes. You know what, I'm going to move this over so that hopefully I'm not in the picture. I don't know, I probably still am. And then you get the electron transport chain, right? Boom. You get from this about 30, 32, 38, something like that ATPs. Now, what happens when you do, we just got our lipids in, right? We just got our lipids in there, okay? We did all that. They finally made it into the cell. They've put it into the lymphatic system, or the blood, or whoever, whichever way it's working for the cell that time, has taken it where it needs. And now what? Oh, what just happened? Now what? Now what's happening? Okay, let me tell you what's happening. Oh, for one thing, okay. What's happening? Fatty acid oxidation. Dude, boom, right into acetyl-CoA. Oh, sweet. It's like the same pathway. When we get to proteins, it'll be the same. Fatty acid oxidation. It skips all this business and goes right to acetyl-CoA. You're like, oh, but it gives off some ATPs. This gives off like 25 ACPs, so we're still good. Way more ATPs with lipid production. Way, way more. There's a side effect, though. Let me tell you what else is going to happen. Okay, so you have all these ketone bodies and ketoacidosis. The beta oxidation step produces a bunch of this whole process. You don't have to know exactly what it is. You just have to know that it produces a bunch of ATP. Now, okay, so you've done this process. Why do we not just always use this? Why is this not better? Why is it not awesome? Okay, because this is actually the preferred pathway, carbohydrates. You sometimes use this. It's good. It's all good because you get way more ATP out of it. However, this puts a bunch. When you do this, you get a bunch. I can't even, a bunch of acetyl-CoAs. A lot. And it floods this. This is a cycle, right? You can't just shove things. You can't make the cycle go any faster. So it's like, whoa, whoa, whoa. This beta oxidation process has made a bunch of these acetyl-CoAs. This is nasty stuff. You don't want this to build up. It makes acetone. It makes all kinds of yuck. So it actually goes into ketosis. It actually makes ketone bodies. These ketone bodies build up in your system and bad things happen. Why? Because again, it can only pump so many here. So you're not getting the 95 ATPs, you're getting ketone bodies instead, and it's bad news. This is ketoacidosis. This is exactly what happens. When this happens, the blood buffer system is overwhelmed and the blood pH drops. This is, again, remember the pH? I said this was going to come up again. Again, we're getting ketoacidosis, which you will see ketone bodies in the urine. This is the first step. You take a blood test. You're going to see the blood pH is super low because, again, this is diabetes. This is why. It produces ketone bodies, and during the early stages of starvation, you can do this for a long time. Prolonged starvation, the brain can switch to ketone bodies and meet up to 75% of its needs. Ketone bodies are produced faster in diabetes. This is indicated by acetone on the patient's breath. This is why sometimes people smell like alcohol. It's because they're producing ketone bodies. And so the carbohydrates, how we got that in, that's the preferred way to do it. If this is broken somehow or whatever's happening, you're starving or you're diabetic or something, you're going to get a bunch. This makes a bunch of ATPs if it works correctly. But this fatty acid, this makes a ton of acetyl-CoAs and it just floods the system. It just goes in here and this can't turn anymore and you get a bunch of ketone bodies. And it's like acetone, it's like alcohol in your breath, and it does kind of some nasty stuff to your body. So you don't really want that. And it can lead to coma and death, which is also what you don't want. So that, I think, wraps it up, folks. I'm satisfied if you are. We will do a bunch of review when you guys get back. Have a great Thanksgiving.